Alright, this is an introduction for lab number 2. What we're going to be doing is we're going to be taking a look at a ball being tossed up into the air, and it's going to be constantly accelerating because of that pesky little thing called gravity. What do we need? Well, we need a computer, we need a computer interface, we need Lab2short, we need a motion detector, and we need a research-grade rubber ball. Let me show you what some of these things look like. This thing right here is the computer interface, and what it does is this is the USB end. It plugs into my computers, usually in the front of them. This right over here is going to plug into the various sensors that we're going to play with in this physics class. Something to note is there are 2 ports on this side and there are 3 ports on this side, and essentially different sensors plug into different sides. These are different size plugs. Please don't force it if it doesn't fit. Try the other side. This right here is a motion detector. You can kind of see, I know it's upside down, but it says motion detector. What this is going to do is this probably has a cable. Note how the cable is nice and neatly wrapped up. Please return it to that position when you put it back. One end is going to plug into the motion detector. One end is going to plug into that white box. Again, if you try it in the white box and it doesn't fit on the first side you try, please try the other side. Now what we're going to do is we're going to first make some preliminary questions, make some predictions of what you're going to see. I don't care if your prediction is right or wrong. I care about the fact that you actually made a prediction. Please do these ahead of time. I don't want you spending the time in the lab doing this, because we are going to be kind of time limited because of the time window we had to squeeze this class into. What we're going to do is we're going to connect everything. It does tell you which side to plug it into, and you're going to set the motion detector to the person in the ball setting. What you're then going to do is you're going to open up Lab2short and go to File, Open, Physics with Vernier. You're going to find the file 06 ball toss, and you're going to open it. That's going to set the motion detector to some settings that work well with this particular lab, and then you're going to toss the ball straight up and down. Make sure that the position versus time graph is smooth, and make sure that nothing looks too awful funky. Make sure the ball stayed over the motion detector the entire time. Once you have a good run, and you only need one run, it may take you a couple to get there, but it is what it is, you're going to print the 3 motion graphs, position, velocity, and acceleration. Then you're going to use the examine button to kind of identify some key regions and some key values. You can also access the examine tool by pressing Ctrl+E. I want you to identify when the ball is still in your hands and when it's in free fall. We're going to look at the position, velocity, and acceleration at some specific points, namely the ball at the top of its motion. Then what we're going to do is we're going to do some curve fits. We know that the position versus time graph should look kind of like a quadratic. I have you fit a quadratic to it. Then what you're going to do is you're going to say, wow, look at that. The coefficient of the t squared term looks a whole awful lot like 1/2 of gravity, so it should look a whole awful lot like -4.9. How close did we get to what we would kind of expect? The graph of velocity versus time should be linear. I have you fit a line to it. How close does the coefficient of the t square, or the t term, compare with what you would expect, which is -9.8? I do have you calculate percent error. Lastly, I have you take a look at the acceleration versus time graph, and I have you calculate the mean acceleration when it's in free fall. Should be really close to -9.8. Think about some reasons of why the ball's acceleration may be slightly different than 9.8. Now, I do want to talk about the graphs a little bit. Let's first talk about the position versus time graph. The position versus time graph, that's going to be my position. This is going to be the time. It should look like a nice, pretty parabola based on this equation just right here. And the reality is it's probably going to be sitting in your hands, sitting in your hands, sitting in your hands, and then you're going to throw it up, and then it's going to come back down, and then you're going to catch it. When you go ahead and you do your curve fits, you are interested only in the region where it's in free fall, so only in this region right there. Again, the coefficient of that term right there should look a whole awful lot like -4.9, which is 1/2 of -9.8. When you go ahead and take a look at the velocity versus time graph, we would expect it to be linear based on this equation just right over there. And indeed, it should be linear. You're going to have this ball, and it's going to be sitting in your hands, sitting in your hands, sitting in your hands. Then you're going to throw that ball up, and it's going to go through free fall, and it's going to look like a nice pretty line. And then it's going to be caught in your hands, and it's going to probably have a velocity of 0. Again, you're only going to do your linear fit in this region right here, where it is in free fall. Again, you're going to do a linear fit, and the slope of the position versus time graph should look a whole awful lot like the acceleration, which should be negative 9.8. Lastly, we're going to go ahead and take a look at the acceleration versus time graph. And what you're going to see is it's probably going to be sitting in your hand, sitting in your hand, sitting in your hand, and then you're going to accelerate it upwards. It's going to then enter free fall, so it's going to have this initial hump right here, and then the ball is going to enter free fall, and it's going to be probably roughly negative 9.8. Then you're going to physically catch the ball. That's going to give rise, give rise to another big hump, and then it's going to be sitting at 0 acceleration. This hump right here is you throwing the ball up. This guy right here is you catching the ball as it comes down into your hands. With all that said, please make sure you do the preliminary questions, and it should be good.